Hi, so it's 30th May and today I have almost completed the below this whole backend thing. uh, Up until this part I have completed the entire thing by basically getting this part ready and removing ChromaDB completely and figuring out how to interact with the different embedders. So basically today I researched some about external APIs, about inference APIs like Hugging Faces. Uh, so there are a few good choices here. So this one was pretty cheap. This is recently released on 28th. I think it's been 2 days only, and it was the entire model was distilled into Qwen 3 8 billion, and as you can see it's just 8 billion model, and the context window is literally just 64,000 tokens. So that's it. I think it's enough for our use case. And also as you can see, if you look at the benchmarks of this thing in the 8 billion model, it trumps the Qwen 3 235 billion model. So there has to be some weight to this, right? Pun intended. And if after that I looked around about which one would be better, the local inference or the Hugging Face inference. So the thing is, I could run it on local, and it would have somewhat significant impact on my local PC. But for a 768 dimensional vector, it wouldn't be that big of a thing. And also the intricacies of 768 dimensions is not that much, it's not that deep, and there isn't much features that are being extracted from that vector if I'm ever going to do that. So that would be counterintuitive. If you put a very heavy let me show you the mtab leaderboard. If you put stuff like this into it, link embed mistral or something, so it's a 7 billion model, you cannot really run it on a CPU, and you cannot run it on a GPU either. But again, why do you need text embedding that crazy? You just need some relevance, right? You just need some semantic relevance. So for that there are simpler models like Hugging Face is Inference. So I found this HF Inference model right here. Let me show you which one I used. I used this thing. It's the BGE base NV 1.5, BAI BGE base NV 1.5. Let's see. So that's this one. So it's pretty good. I mean, for what it's worth, it's absolutely provided by the HF Inference API, so I can call that on and on, and it will give me a pretty good representation of that vector, so that I can do the writing part of it. So this is the embedding model, and then I have chosen the model name as Deepseek R1 8 billion, and I prepared the APIs for these things. Let me show you how I prepared the APIs. So first of all, I also had to make the other option, like the Gina API, which is the really state of the art model. Let me see where it is. So yeah, it's on the 21st rank, Gina embeddings v3, and it is totally it can run on CPU as well, because the number of parameters are just 500 million. So this can be stored inside the memory of a computer normally, and it can be run that way also. Or I could try something about this also. Let me bookmark that, maybe I'll look at it later. But yeah, for now we can use the HF Inference text embedding model, and for that I have made this API. Let me show you the main document here. So this is the document in which I search within, and I basically do this aggregation pipeline and do a filter search for doc ID, and in order to search through it, I need to make the vector index in the first place. So that's also really important. And yeah, so basically we have this embedding model. There you go. So if the embedding model is in the Olama list, let me show the Llama list. If I gave it the nomic embedding model in the main.py file, it would just run it locally like it usually would do. But since I'm using an external API and using BAI model 768 dimensional, it would call this it would go into the else block and call the inference client. Now what is the inference client? Let me take you there directly. Yeah, so I think I stored it somewhere else. Yeah, here it is. Yeah, it's coming from here. So this is the inference client, HF inference, and it takes the HuggingFace token. And after getting these things, I chug it into this, and first this thing runs. What is it? Yeah, so first it processes and then it makes the rack query. So let me quickly show you how the rack query is now. Query.py. So we have set up this external LLM function. In this, what is happening is it is deciding between if the inference client is provided. We need not define the inference client again, because let's say if we want to use a different provider for LLM and use a different provider for text embedding, we can do that as well if we provide the inference client as none. So what will happen is we can use the Novita LLM if we want to. So yeah, and after that we can just do this rack prompt for the user, and then this happens just like that, and then we can return the response from it. So this is the same as before. Multi-embedding average is same as before, and the only change which has happened here is I have put in the different considerations for the embedding model, the embedding collection, and index name, and Novita and LLM provider name. I have done all the refactoring which is necessary, and all the abstraction that's necessary also, and beautified the code a little bit, and also made it a bit more modular. And after that I went ahead and created the index, and found the relevant chunks, and got the relevant chunks, made the query to give to the LLM, and then gave it to the LLM directly. And this is the file which I changed in order to make that vector index which was changed. So this is the vector index. This was changed, and I have put in the type filter. So basically we can now put in different stages. First of all, we can put in the search vector which we want to search in as a similarity dot product search, or and now we can also filter by document in order to look inside each document and then search inside of it, instead of a global search. Although we can create another index which does not have this filter thing, and thus we can do that without the filter. Basically it would be a global search among all the PDFs, and we can get the answer from that as well. And basically the token calculation part, we can I basically estimated that since we have 64,000 tokens, and we have all these text the JSON file is almost 1,000 tokens. Basically if we took a really huge file and it required a really huge summary, it would be almost 1,000 tokens, and we got 63,000 tokens left. And 63,000 tokens is almost 2.5 lakh characters, and if we divide that with the number of chunks, we get basically that many characters as the input in the prompt. Basically we can just shove it into the rack prompt, and LLM will basically handle it all. That would be basically the maximum utilization of the query which we are going to give, since they are only providing it per request basis. So that's how it goes here. And we have already seen the code base how it is, and what all has changed here. As you can see, I've made some refactoring changes also, and improved the quality of the code base also. And also the change that I did, what I upgraded the version from 2 to officially 3, so we are version 3 now. Congrats. So basically this was the output, right? So I've recalculated all the things, and this is what it looks like. So this is the first scheme to promote organic farming by making available organic inputs. So what we can do is we can actually you know see the document and compare it one by one. Let me check. We have the JDs. No, yeah. Which one was it? 22111. Yeah, there you go. This is the document we are talking about, and we have this clear cut put objective and implementing agency. Let's see if it so yeah, it got the objective all right. To promote से लेके इसने waste तक it got it. To utilization of organic waste. Yeah, it got the entire, I think, part of it. And then we have the implementing agency and COF, and I don't think I put in a really field for that. If I put a field for that, it would have got that up as well. There is no eligibility income criteria, so since there is no eligibility income criteria, it didn't mention it in the summary as well. So there are other this thing, tiers for different people, subsidy ceiling of per calf, and the different things are for SC/ST as well. So these are the scheme verticals, and then we have the conditions. These are the document requires unit wise. Let me check. Unit. Yeah, I don't know where it got it from. Let me check. Yeah, there you go. We have the beneficiaries as well, and application how to and application status, and these are the preferences. Oh yeah, it definitely got the for subsidy category thing. So it has 50% assistance for SC/ST as was mentioned in the document as well. And then there are different organization names. Didn't mention NABARD. Let's see. Yeah, it mentioned NABARD, and all the other summaries. It should have it. I think it has. I think it's a pretty decent summary of a document, and it got the crux of the entire thing. Let me see if it got the TFC all right. Total project cost. Yeah, there you go. Yeah, so it got the subsidies all right, and the summary quality is also acceptable, I think. And then we can also add a little bit of more questions in order to make it understand it better, what we want from it. And yeah, in PM Awas Yojana, it got the eligibility income criteria all right, because it's explicitly mentioned for different groups, for different underprivileged groups. And then it got the links quite well, I think. So yeah, that's all the results and the code base for today. I think this document projection pipeline is pretty much done. All that's left is basically searching and a front end. So next, now I will work on this part, the client part. So we already have the summary and we already have the search results. So what I'm going to have to do is just make the client and the query, and then it will return the relevant chunks from as a global search on the entire this database, this doc chunks database. As we have this, it currently searches through within each document. We have the API for that part, and now we want to search inside as a global storage. So we want to look inside each scheme, and we want to decide, let's say, which scheme is best for me or something like that. We can do that also. And then we have the summary documents also. So these two things are gonna be on the top of the priority list now. And yeah, that's all for today. Goodbye.